All right, good morning. Happy Friday. I feel like this week, I feel like the week after break is always a bit exhausting. I feel like based on the events of our country this week, it's especially exhausting. Um, Man, experiencing stuff like this, like I feel like in the past year we've experienced some pretty significant moments, and doing that is exhausting in itself. So I hope that you are finding places um, that you can process and figure things out, and some time and space for that. I get that different people are going to be affected differently in the way we all see things. So I know for me on Wednesday, I was getting ready to get the quiz ready and was doing this, and I got an email from Dr. Tucker, and it was canceling a meeting because of the things that were happening in our country. And I was like, what? And then I had a hard time. I couldn't work after that. That was hard. We spent a lot of time watching the TV, like, what is happening there? So hang in there. Find what works for you. Find ways that you process best. Find ways that that work, I don't know, just for you in finding ways to take care of yourself. If there's ways that we can help, let me know. Counselors are available, obviously. I'll gladly talk with any of you about any of it. And we'll just keep working with each other and supporting each other in what we do. One of the things that I appreciate about Highland more than anything is the various people that we have as a part of our community. And it's a unique spot to be in. I graduated from Highland, and I didn't realize how awesome that was until I was out in the rest of the world. So we get to experience so many people, and that shapes our perspective moving forward from here on out. And so keep being awesome. I'm always encouraged by all of you and the things that you're doing and the way that you're going to build into and support the next bit of what our world looks like. So keep it up. And so, like I said, if there's ways I can help, let me know. It's always weird to think about the things that are going on and then head out and be like, let's do physics now. And it's like, oh man, do those things even connect? And sometimes they don't, except the thing that I do know is that the more we do to get stronger and to get better in what we're doing, that the better off we're always going to be. So we're going to keep moving forward. And like I said, keep a pulse on yourself on things that you might need help with, or things that might help you to be in a good spot moving forward. And we'll just keep being our best selves and making the world a better place. So I am grateful for each of you, and thank you for coming today and for this stuff that we need to do. Then bring it out here and charge it over there.
I need that one.
Okay. So no. I need this one on here. So I'm having all kinds of technical issues today. My goodness, my iPad is being obnoxious. My computer is being obnoxious. So we're just gonna go with it. We're gonna see what we can do and go from there. I'm gonna talk about. I didn't turn this on yet because I wanted to get a few more percentages than 3. I'm at 10 now, so that's good. We're heading in the right direction, and I am charging it, so we should be in good shape. But I'm going to jump on here, and then we'll get the board going here. We'll also, with this, I will, that's not right. There we go. I will kind of walk through kind of the different things that we're dealing with, and figure out, we'll take some practice problem questions and work through some things. So the biggest thing I want to talk about is just this idea of what's happening when we're doing work and power. And work and power go hand in hand. Work is how much is getting done by your force and your distance. And then power is your work divided by your time. I'll go ahead and share my screen and do this. There we go. Come on, come on. There we go. So, so work and power go together, and work is, again, how much is getting done. Power is how much you do in that time. Another way of writing it is that power equals force times distance over time. And one of the practice problems that we'll do, I'll help you work that through and do some stuff with that. So that's kind of where we're headed. There were two things that you were working on this week. One was a lab, and I'll talk about that. And two was your practice problems, and we'll do some of that today in class. And so the lab I want to talk about first, you had steps. And so usually we do this out in the hallway at school, steps, ramps, etc. And you needed, you know, when we're talking about the work that's being done, we're talking about the work that is being done when you're overcoming gravity. And so the force to overcome gravity, in the beginning of that, I walk you through how to figure out the force of gravity on you. So you go from pounds to kilograms to force. And then you also need the distance. And so to get the distance, measuring just the height of one step works well for that, and then multiplying by the steps. And so let's say the height of your step, I think in the one that I did in my basement, is 20 centimeters. And so you need to get that into meters, 20.20 meters. And so then you could count the number of steps. So I think I had 13 steps times 0.20 meters, and that gave me 2.6 meters for the total. And in most houses, you're going to run somewhere between like 2.5 and 4 meters, depending on the heights of your ceiling and how your house is set up. If you're in a situation where you're in a like in a larger building, like an apartment building, or or if you're doing the steps outside somewhere, there's different combinations that you might have. And so it might be taller, it might be a little shorter, whatever you have is fine. So you're just measuring that vertical distance from there. It did come up if you measured it in inches, and 1 inch equals 2.54 centimeters. That's sort of helpful. It's sort of not. It can get goofy on your calculations. So what I would suggest if you measured it in inches is to just go online and type in like distance converter or inches to meters or something, and it'll pop up, and you can just put your number of inches in there and it'll tell you how many meters you have, and you can just do it that way too, is another option. So you do that, you measure yourself walking up and then running up. Again, that's relative. So if you want to walk up quickly and slowly, that's fine, just as long as one of them is quicker than the other, and then calculate from there. Does anybody have any questions on the lab that you needed to do? Okay. Second thing then is doing the, I can't even think, you guys, is doing practice problems. And so the practice problems that we have, some are more straightforward than others. However, I want to talk through 12, 14, and 15, I think. It's the last two, and then number 12. Number 12 is what I'll start with. And number 12, oh, it doesn't want to, not that, not that, not that, not that. Open up the wrong thing. We're going to go through it this way. I had it up, and then I must have closed it. There we go. Number 12 asks this. It says, a swimmer goes 50 meters in 40 seconds, and I'll show you my board in a minute. So the distance here is 50 meters. Time is 40 seconds. And it says a power of 227.5 watts is used, and we're going to solve for the force. 11 and 12 are similar. In 11, they're looking for distance. In 12, they're going for force. And so the basic rearrangement ends up being the same. So you can, if number 11 got you tangled up, I'll talk through what you'll need to do on that while we're doing this one too. So because of the variables that we have power equals force times distance over time. And we'll be solving for force in this one. And so we can rearrange this. We can multiply both sides by time to bring that over to the other side. So we have time times power equals force times distance. And in this situation, we're solving for force, so we'll divide both sides by distance. In number 11, you're solving for distance, and so you would divide both sides by force. So I'm going to divide by distance here. And so I have force equals time times power over distance. And so now I have the information that I'm looking for. I have 40 seconds times my power of 227.5 watts divided by my distance of 50 meters. And so then we can take and do our calculations on this. Let's take 40 times 227.5 and then divide by 50. And I end up here with a force of 182 newtons. And so that's what we're looking at. This one, like I said, is for number 12. And I'll leave it here if you want to take a screenshot before we go on to the next thing. Any questions on this one? And like I said, number 11 is the same. The only thing that happens differently is that when you're in this step here, you'll divide both sides by force, leaving distance on this side independently. All right, we'll go on to the next two. And the last two that are on there are just, they are showing what we can do. They're not problems that will be showing up on a quiz or a test, but it's looking at the way that we have all these different layers within physics that we can put together in what we're doing. And so that's kind of where we're headed with it and what we're trying to figure out. But there's a bunch of layers that go with it. And so this is our kind of heavy lifting to make us stronger in seeing how all the pieces go together. So let's look at the first one. We have number 14 is about Superman. And I'll show you my board again in a minute. Superman goes from 0 meters per second to 50 meters per second. So he starts at 0 meters per second, so that's our VI. He ends at 50 meters per second, so that's our VF. And so they're both meters per second. If you happen to flip them, you just end up with a negative sign later. Distance is 450 meters. And his mass is 75 kilograms. Then the question asks, calculate the amount of power required. So we know that power, I'm going to actually put this down here. We know that power equals force times distance over time. The only thing in this problem, in the variables that we have that fits into here, is the distance. So I'm going to put this here. I'm going to say the force that we'll have times the distance of 450 meters divided by the time that we'll have. So that's what we're looking for. Those are all the pieces we need to get from the information that we have. So let's get our time first. Our time's a little bit more straightforward on what we need. And so we can say, well, time is what we're looking for. And so equation 2 has VI, VF, D, and T. We can say D equals VF plus VI over 2 times T. That's one of the equations that we use in the Big Four. It's equation 2. So we have the information to solve for time. In this situation, I'm going to put my numbers in first because it allows it to be just it makes it a little bit more clean. So I'm going to say 450 equals 50 meters per second plus 0 over 2 times my time. I'm going to bring this down here. So I'm going to say 450 meters equals 50 plus 0 over 2 is 25 meters per second times my time. And then to solve for time, I'll divide both sides by 25 meters per second. So I get rid of that, and it allows me to have time is equal to 18 seconds here. So that's helpful. That's part of what we're looking for in our calculation. We have 18 seconds. So Superman flies for 450 meters, ends up being in 18 seconds. He's starting at 0 meters per second, going up to 50 meters per second. And so getting to the force, we know that force equals mass times acceleration. So I'm going to write that part here. Say force equals mass times acceleration. We know his mass is 75 kilograms. And we're going to solve for acceleration. Okay. I'm going to box this off. And we can say, now we have VI, VF, D, and we're looking for acceleration. Again, this is our heavy lifting. There's lots of pieces to it, but it's not something that you'll have to reproduce on a test or a quiz. So hang with me on this one. So we know equation 4 says VF squared equals VI squared plus 2AD. Cool. Let's solve for A. Do that by subtracting VI squared from both sides. So we have VF squared minus VI squared equals 2AD. And we need to get A by itself, so we'll divide by 2D on both sides. That leaves us with A, VF squared minus VI squared over 2D. So we can say 50 squared minus 0 squared over 2 times 450. So 50 meters per second squared minus 0 meters per second squared divided by 2 times 450 meters. Almost there. When we take this, we get an acceleration. So 50 squared minus 0 squared, doesn't matter, divided by 900 ends up giving us 2.7 repeating, so 78 meters per second squared. That's our acceleration. Almost there, because force equals mass times acceleration. We can put that up here. Let's draw an arrow that's heading there. So 2.78 meters per second squared. And when we multiply that, 75 times 2.78 gives us 208.5 newtons. That force goes in here. So that's a lot of stuff to get through to get to the information that we need for the power. So we have this. That's what's given to us. We use this to figure out our time. The distance was given to us in there. And then we use the rest of this to figure out our acceleration. That then helps us figure out our force that then we can put in here. Now that we have that, we can take our 208.5 times 450 and then divide that by 18 seconds. And we're left with a power of 5,212.5 watts. A whole lot of stuff, but it shows us just kind of how all these pieces overlap, and then it gives us practice in getting there. So I'm going to set up, I'll leave this right here. I'll keep the glare out of it if you want to take a screenshot of that, and then I'll shift it again in a minute, or in a moment, not a full minute. And does anyone have any questions on that one? Slide it up. That was number 14, I think. Yeah, it says it on the top of the board. And then we'll walk through number 15. I know questions like this can get a little bit just like, what are we even doing? But on the flip side, it's just sort of an interesting thing to be able to see how we have all of these pieces that we can do things with. I'm going to erase this. We'll set up number 15. Number 15, I took the data from like actual stuff. So it's actually what happens with the car we're going to talk about here. Excuse me. Number 15 says that a Honda K20A engine accelerates from 0 to 60 meters or miles per hour in 6.1 seconds. So the 0 to 60 just helps us just socially know what we're talking about when we're talking about the cars here. That's not actually going to be helpful. The time is 6.1 seconds. But the measurements that we'll use for our VI and VF are the meters per second measurements. So 0 meters per second, and then VF equals 26.8 meters per second. So our measurements, we don't measure things outside of science in meters per second. We use miles per hour just socially. Most places don't measure things in meters per second. Usually they use kilometers per hour, which makes it seem like you're going really, really, really fast, even though you're not going quite as fast. it's like 60, it's about that, like about 60 miles per hour is about 100 kilometers per hour. And so if you're driving a car that's measuring in kilometers per hour, it looks like you're going 100 and you're like, wow, and you're just driving at a normal speed. It gives us our mass here of 1,260 kilograms. And then we need to find the power again. And so again, I'll stick this down here. We know that power is equal to force times distance over time. And in this one, the only thing that we have straight from the variables in the problem is that our time is 6.1 seconds. And so we have to figure out what our force is. We have to figure out what our time is. And so this one is actually a little bit more straightforward because we don't have, or distances, we don't have as much rearranging to do. And so let's figure out our force. We know that force equals mass times acceleration. And so we have 1,260 kilograms, 1,260 kilograms, and we'll solve for the acceleration. And we know that acceleration is equal to VF minus VI over T. And so we have those variables. We don't need to rearrange anything. We have 26.8 meters per second minus 0 over a time of 6.1 seconds. And so that gives us an acceleration, 26.8 divided by 6.1 gives us an acceleration of 4.39. There's a whole bunch of stuff here. And so we have 4.4 meters per second squared. Then go ahead and close the door. Okay, then go have a snack. So our acceleration here is 4.4 meters per second squared. And then we can get our force by multiplying that by 1,260. So 1,260 times 4.4 gives us 5,544 newtons. This here is the force that we need for here. So in order to go at this acceleration at that mass, we have 5,544 newtons. That's the first part. The second part that we also need to have is our distance. And again, we don't have to rearrange because equation 2, VF plus VI over 2 times T is what we have for distance. And so we can say 26.8 plus 0 meters per second over 2 times our time of 6.1 seconds. So 26.8 divided by 2 gives us 13.4. And then we can multiply that by 6.1 seconds, and we get 81.74 meters. By the way, that's a teeny tiny amount when you're going from 0 to 60. 81.74 meters. So a soccer field and to like goal to goal is 100 meters. And so 81.74 is about 4/5 of that. And to get from 0 to 60 in that is definitely incredible. So we're going to say 81.74 meters in that. And then we have our time, we have our distance, we have our force, and now we can solve for our power. So we can say 55.44 newtons times 55,544 newtons times 81.74 and divide by 6.1 seconds. We have to have a power here of 74,289.6 watts. Huge amount of power in order to do that. Questions on this? All right, I'll leave that here for a screenshot. You can get what you need. Are there any other questions on any of the other practice problems that would be helpful to go through for this? No. Do this. I'm going to be done sharing my screen. All right. So things to be thoughtful of. Thing one is to make sure that you are getting things caught up, not just for this class, but for any other class. Sorry, that you need to be getting caught up in. For this class, I'm still taking stuff, get it in, get it taken care of, get your work done, get things taken care of. If you have questions, feel free to email me. I have office hours from 11:45 to 12:45 today, so you can jump on there. There's stuff if you just need to make a plan, come on and talk to me. I can gladly and easily help you out with that. We will always keep moving forward. For us, we have next week we'll talk about energy, and then conservation of energy the following week, and then talking about then taking the test and the review that last week. So we're heading there, we're getting wrapped up, and we're doing the things that we need to do. So as we're doing that, keep moving forward. Like I said earlier, I appreciate you all greatly. I thank you that you're coming here and you're working hard and you're trying to figure things out. I appreciate that you are positive, awesome people, and that you're always working to make this world a good place. So thank you for the things you're doing, both in class and in our world, and have an awesome weekend. I'll hang on if you have any other questions. Other than that, we'll see you later. Bye-bye.